All right, boys. 8.3, proving similar triangles, okay? We know what similar triangles are already. They're triangles that have the same shape, raised to the same, they have congruent corresponding angles, and they have sides, corresponding sides that are proportional. Today we're going to actually prove similarity. Similar to how we prove congruency. Remember we had side, 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 angle, side, angle, angle, side, angle, side, angle, hypotenuse, leg. Well, there are a bunch of similarity postulates or theorems that prove that two triangles are congruent. And the first one is the AAA postulate. The AAA postulate basically states that if you have three corresponding congruent angles, okay, then the triangles are going to be similar. So you got two triangles and the corresponding angles are congruent, all three of them, bam, the two triangles are similar. Easy enough. Kind of like Eddie said, pretty self-explanatory. Okay, number 2, or theorem 62 rather, AA, okay? If two corresponding angles are congruent, the triangles are similar. Yes?
Isn't this the exact same thing that we already...
No, it is not the exact same thing that we already learned. We learned how to prove congruency. Congruency is when it's the same shape, same size, same angles. This is similar. No, what you're thinking of is the no-choice theorem. And the no-choice theorem is why the AA theorem can work. Since I have two angles that are already congruent, okay, doesn't the third angle have to be congruent? Didn't we just state in the AAA postulate that if all three angles are congruent, that the triangles are similar? So if just two corresponding angles are congruent, you're going to have similar triangles. So since A is congruent to D and B is congruent to E, you have two corresponding congruent angles in two different triangles, so those two triangles are similar. Does that make sense? Does that make sense, my man? Okay, but good memory. They have to be corresponding and congruent, yes, sir. Just exactly like the no-choice theorem. Okay, just like the no-choice theorem. In fact, I repeat, it's because of the no-choice theorem that this works. If A were 80 and B were 30, and D was 80 and E was 30, C would be what? F would be what? Okay, we know that because of the no-choice theorem. Since the no-choice theorem is valid here, now I have three corresponding congruent angles. So again, if all three corresponding angles are congruent, you got similar triangles. If you've got two corresponding congruent angles, then the triangles are similar. Does that make sense? Thank you very much, guys. Now, this one's very, very, very close to side-side-side congruency. If you notice, though, this is side-side-side similarity. I went ahead and I labeled the similarity next to the side-side-side to differentiate which one I'm using. If I just use side-side-side... Okay, sorry about that there, guys. Side-side-side congruency means that all three corresponding sides are congruent. For this particular situation, for similarity, side-side-side similarity states that the ratios of corresponding sides are proportional. Then the triangles are similar. So for ABC to be congruent to DEF here, AB would have to be proportional to DE because they both correspond. AC would have to be proportional to DF because they correspond. And BC, of course, must have the same proportion to EF because they correspond. So when you have corresponding sides are proportional, you're going to have side-side-side similarity. Does that make sense? Okay. All right. Now, I know that some of you are still writing. I'm sorry, but it is on video. Okay, so let's put this to practice. For example 1 here, I want you to solve for x. But I haven't given you any information about these triangles. I haven't told you that they're congruent or that they're similar or anything. All I have here is triangle ABC with base angles 40 and 70, and I have triangle DEF with base angles 40 and 70. So what can we prove right off the bat? Juan? Absolutely, right off the bat, triangle ABC is similar to triangle DEF. Why? Because of angle. Very good job, gentlemen. Nice. Now that they're similar, I know that their sides are. Good job. So Juan, set it up. Tell me what proportion did I set up? Okay. 9.6 to 8 because DE, okay, corresponds to AB. Very good. And then? No. If you started with 9.6, you got to start with that same triangle. X over 10. Very good. You could have also done 8 to 10 is congruent to 9.6 to X. You could have also done 8 to 9.6 equals 10 to X. Either way, I promise you, you're going to get the same answer. And if you cross multiply, you're going to get 96 divided by 8. So X is going to equal 12. That's the power of similarity. Does that make sense, son? Okay. Now, we got side angle side. Similarity. Again, we have learned about side angle side congruency. That means that when one corresponding congruent angle is in between two corresponding congruent sides, then the two triangles are congruent. Well, now we're working with similarity here, gentlemen. So it says if two corresponding sides are proportional and the angles between them are congruent, then the angles are similar. If you look here at ABC and DEF, okay, I've got AB is 12 and DE is 3. So that's 4 to 1. And I've got AC is 20 and DF is 5. That's 4 to 1 as well. So are the sides proportional? Yes. Is angle A in correspondence with angle D? Absolutely. Are they congruent? 35 is not congruent to 35? No, no, yeah, thank you. He thought I meant the whole triangle. No, I was talking about the angle themselves. But now, he did answer this correctly. Are those two triangles congruent? No. Very good, Alec. What are they? They are similar because of side angle side similarity. Yes, the question was, when we have proofs, do we have to use this? Yes, that's what we're going to do next. It depends on the proof. It depends. Depends what they're trying to prove. If they were trying to prove that BC was proportional to EF, yes, you'd first have to prove that they were similar. And then once they were similar, you could use the definition of similarity stating that all corresponding sides are proportional. Yes, once you prove that ABC is similar to DEF, then that means for sure BC will be proportional to EF, definition of similar triangles. Because again, similar triangles or similar polygons, same shape, congruent corresponding angles, corresponding sides are proportional. Thank you, gentlemen. May I continue? Okay. All right. So let's see what we got here. For problem 1, I got ABCD is a parallelogram. I want to prove that BFE is similar to triangle CFD. Now I helped you out here and I gave you the last statement, but that's it, okay? What would my first statement be, do you think? The given, abso-freaking-lutely. So I got ABCD is a parallelogram, and that's going to be, of course, given. What would step 2 then be? If I know that ABCD is a parallelogram, what do you think we would be looking for next? He had his hand up first. AD is parallel to CD? No. Okay, AD is parallel to CB, but that's not going to help you here in this proof. If you think about it, hold on, just to help you guys out, we're trying to prove that BFE is similar to CDF. So using AD parallel to CB is not going to work. But we do need another one that shows parallelity. There you go. CD is parallel to AB. Why? Definition of parallelogram, abso-freaking-lutely. Okay? Yes, sir. Okay, you can do it a couple different ways. What my boy is saying here, though, is that you've got this Z right here, right? Well, you've got a Z that way. I'm not wrong here, guys. And I've got a Z this way. Okay, so no, I'm not wrong. You do have a Z this way right here. And if you just wait a second, I'm going to show you. Angle CDE is congruent to angle AED. Is it not? And that would be parallel lines, then alternate interior angles are congruent. Now, could you have said that angle DCF is congruent to EBF? Yes, absolutely you could have. I'm not going to, though. But you could have done that, yes. So I'm going to get rid of that for a second. Now, I went the route of vertical angles. Aren't DFE congruent to EFB? Okay, because of vertical angles. Vertical angles are congruent. And then finally, BFE is similar to CFD because of angle-angle. Now, if you guys had chosen to make angle DCF congruent to EBF, you would not have needed the vertical angle part because you already had two angles. If you wanted to choose to prove that all three corresponding angles were congruent, you could have done that and used the AAA postulate. But the best way here was just to find two. But I'm very proud of the fact that you guys saw that you could have proved this guy and this guy, or you could have proven this guy and this guy. So I'm very proud of you there. Okay? And then the easy one that I used was, of course, the vertical angles. Okay? Does that make sense? Okay. Let us continue, please. Okay. Now here we've got that LP is perpendicular to EA. N is the midpoint of P. P and R trisect EA. And we want to prove that triangle pen is similar to triangle PAL. Okay. We say the first one, let's do a given. Okay. LP is perpendicular to EA, absolutely. Now, from knowing that LP is perpendicular to EA, what information can I extrapolate from that? What are the right angles? Yeah, what are the right angles? LPE and LPA are right angles. Absolutely. Why? Definition of perpendicular lines. Very good. Now that I know that LPA and LPE are right angles, what can I say? Absolutely, gentlemen. LPE is congruent to angle LPA because right angles are congruent. Next. Next given. Okay. N is the midpoint of angle, not angle, that should be of LP. Sorry, not angle. I was trying to get fancy and I messed up. It's of LP, side LP. N is the midpoint of LP. I apologize. And of course, that's just given. Okay? What else? We'll get to the proportions in a second. Let's just write down all the information first. You could have gone that route, though. So Ln is congruent to Pn because, of course, definition of midpoint. Now what? No, not yet. P and R trisect EA. Of course, given. If P and R trisect EA, excellent, sir. EP is congruent to PR is congruent to RA because of definition of segment trisector. But now that we know that Ln is congruent to NP, okay, and EP is congruent to PR and congruent to RA, what can I say proportion-wise? Sir? How is it proportional? 2 to 1. Very good. Okay, think about this. Let's show you first. LP is the whole segment, correct? Doesn't N cut it in half? So isn't Ln half of LP? So LP corresponds to NP in a 2 to 1 ratio. And PA, okay, is proportional to PE, also in a 2 to 1 ratio. Isn't PA twice the size of EP if EP, PR, and RA are congruent? So now I have also PA is equal to 2 to 1 ratio. So this would just be definition of proportions. So now that I know, okay, that PA is proportional to EP and Ln is proportional to the whole entire LP, I can prove that. What is that? That is not what I wanted. Okay, so we're gonna do a little something here. We're gonna put this bad boy right here. We're gonna erase this sucker. I apologize. I have no idea what that means. Yeah, no, I made an error. I'm human. Okay, so triangle PEN is similar to triangle PAL because of side angle side similarity. Does that make sense? You got this? All right, come on up. You're going to do the next one. Let's go. All right. Shh. Relax. Relax. Okay, actually, here you go, buddy. No, you don't want. All right. He doesn't want the mic. Okay, so I'm going to have to be a play-by-play. He says to first put the given, which is KH. He's numbering it. Leave him alone. And you can abbreviate. You can put alt, exactly.
Assistant Principal at Columbus High School. Please leave a detailed message and phone number so that I can return your call. Thank you and have a good day.
To the hypotenuse.
When you are finished.
GJ of right triangle
send this message, press 1. To play your message, press 3.
G, H, J. Very good.
For today's plan announcement.
We're out of time.
Give us 1 second. Okay, so we have here we have here another interruption. 1 second. Okay, we're back. And George already put very correctly that KH is the altitude to the hypotenuse GJ of right angle GHJ. Since he noticed that this is a right triangle GHJ, he went ahead and decided to state that angle JHG is a right angle because of the definition of right triangles. Since angle H is across from GH and GH is the hypotenuse, angle H has to be a right angle. Now for step 3 here, he said that angle GKH is a right angle. Definition of altitude. He could have also put, I think he's going to put it now, angle JKH is also a right angle, okay? And it is also a right angle because of the same reason as step number 3, which is definition of altitude. Okay. Now he has that KH is congruent to KH. Okay, that is correct, but it's not going to be helpful for this proof.
Can we go?
No, you're doing great. I'm very proud of you. It's not going to be good for this proof. For this proof, think about it like this, my man. Let's look at the triangles we're trying to prove first, sir. We're trying to prove that KHJ is similar to HGJ. Let me give you a little hint. For the big triangle, don't I already have a right angle?
Yeah.
For my little triangle, don't I have a right angle as well?
Yeah.
See what I'm saying? So, therefore, isn't J part of both triangles?
Yeah, so J.
So, angle J would be congruent to angle J. Very good. Because of reflexive. Very good. And now, George, how many angles do I have that are congruent now?
3.
3? No.
Oh, never mind. I keep thinking.
You have
I keep thinking of the.
this H right angle, this K right angle, and then you have this J.
Yeah.
So I have 2 angles that are congruent. So is that enough to prove similarity?
Yeah.
Okay, do it.
So I just put triangle KHJ.
Correct. Triangle KHJ is similar to triangle HGJ. Very good. And that's going to be similar because of angle. Fantastic. Well done. Good job, good job. All right. Last, do you have a question, son? The next one is not a proof. The next one's pretty easy, but you can tell me how to set it up if you want. Okay? Thank you. For problem 4, guys, last one, so let's just bear with me, please. It says that the sides of one triangle, so you got a triangle, and the sides are 8, 14, and 12. Now, they say the sides of another triangle are 18, 21, and 12. They want you to prove that the triangles are similar. Okay? The numbers are not corresponding because, of course, if they were corresponding, that would mean that 12 and 12 are equal, and that's not similar. When they're similar, they're proportional. Let's think about this. Think about setting up together short sides, middle sides, and long sides. What are my two short sides here, son? 8 to 12, correct? So as far as the short side is concerned, now it is not 3 to 2, but you keep saying that. 8 to 12 is 2 to 3. It depends how you would write it, but the way I'm writing it, from 8 to 12, it'd be 2 to 3. But correct, sir. If you went the other way around, it could have been 3 to 2. Choose one and stay constant, though. Now, what is my middle side? You got middle side 12 to 18. What does 12 to 18 equal? 2/3. And my long side? What about my long sides? 14 to 21, which is also 2/3. I have proven that all three corresponding sides are proportional. So therefore, that is my proof that these two triangles with these two given sides would be similar. Does that make sense? Thank you very much. Have a great day. God bless you.